If you are a scientist, one of the important parts in statistics you need to understand is the difference between a population and a sample. And this is actually one of the main reasons we use statistics, is to be able to infer from a sample what is happening within the population. So what is the difference between these? The population is the group on which the information is being gathered and analyzed. So some examples of this are if you're studying a specific disease and you have a collection of people that have or don't have that disease, the population would be every person who has ever had that disease. That would be the entire population. If you're doing something like soil analysis and you're picking different soil samples from a given area, the soil would be all of the soil on the planet or all of the soil within the specific area that you are studying. And if you're looking at a specific solution, your population would be all of the molecules and particles within that solution, versus a sample would be a sampling of those particles or molecules from that solution. So that's what your population is. On the other hand, your sample is a smaller, more manageable version of the larger group. And one of the things that we want to do with our samples is we want to make them representative of the population. We don't want for a sample to not be completely representative of the population. So examples would be if you were studying a disease, a smaller group of people that have that prevalent disease, instead of trying to find every single person with the disease. If you are studying soil samples, you would choose several soil samples from around a given area instead of collecting all the soil from that given area. And then if you were doing something like analyzing blood, instead of draining all the blood from an individual, you can just collect something like 5 microliters of serum and run your analysis on that instead. You're not measuring all of the molecules within the body, you're taking a representative sample of that population. So why do we use samples? Essentially, practicality. It is very hard, if not impossible, to actually measure the entire population. Think about soil. If we were analyzing soil, even just of a given area, the having to take out, even if we were just analyzing the topsoil, having to take out the soil from an entire area or an entire state would just be, one, completely impractical, and it would also carry a lot of risks or consequences for that. So it's essentially impossible to run a study on an entire population when that population is large enough. Now, when you have some rare diseases, there are cases where you can actually run a study on the entire population because there's only 10 to 20 people who have such a rare disease. Another reason we use samples is time constraints. It's very difficult to look at a population, even if it was possible, within the time that we're given to perform studies. So we would basically never be completing research if we were always trying to analyze the population instead of analyzing a sample. And then we have resource limitations. So we have to have money to fund our research. We have to have facilities to fund our research. And so most studies don't have the resources and the time to sample the entire population or to get data from the entire population. So samples are really important to the work that we do. And what's important to know is there's a lot of different types of sampling methods, so way that you generate your samples from a given population. Now, these are good to know and have in the back of your mind, but most of the time you're not going to be exactly using these within science, because even some of these, this is really theoretical ones, taking from the assumption that you have availability to the entire population. So the goal of sampling is to create a representative sample of the population. So you want your sample to look as close to the population as possible. So a key way to do this is called random sampling. So essentially each member of the population has an equal chance of being selected. Now, this can be possible. Let's say you're taking soil from a given area. You could just randomly put down a map and then create random points across that map through a random number generator or coordinate generator, and then go around and collect those random points. That's actually somewhat feasible. This tends to be unfeasible if you're working with something like human studies. If you're working in human studies, you typically don't have access to every single person in the population that you can then randomly sample from. You have access to a specific number that volunteer and consent to your study. And so some of these are not going to work as well when you're talking about populations with more restrictions in access. A stratified sampling is dividing the population into distinct groups based off of some shared characteristics and then randomly sampling each group. So if you were working with humans and you had the entire population, you could divide the population into distinct groups based off something like socioeconomic class or race or something like that that may be important, and then you sample from those distinct groups. So you may take, there's 3 each from each of those groups, and you're sampling randomly within the subgroup, but overall, you're making sure that your overall sample is more representative of the population. So one example of this is if you ever try to apply to a military service academy, in the US at least, the different national legislatures can nominate so many people to fill the application pool. So basically, you're not going up against every other person in the nation to go against that. You're going up against so many people within your state. And so they have to select basically across the US. It's actually a very representative sample across the US of the states because they stratify it by state and then they select from that stratified sample. And then you have systematic sampling. So this is selecting the every kth element from a list or ordered sequence. So this is really good whenever you're in manufacturing. You have access to the entire population of the items that were manufactured, and then you can grab every 10th element and run a QC check on it. So these are 3 different ways you can do it. Again, this is going to be helpful, especially if you're dividing people into groups. You might use these samplings to divide people into those groups. It's going to be less helpful to know or to implement these techniques when you don't have access to the entire population. So again, these are good to remember and also good to be able to critique and understand different research designs, but you might not be able to implement these as easily within your science. So within that, now that we know how to get our sample and what our population is, we need to understand the difference between population parameters and sample statistics. So a parameter describes the entire population, where you have a few different parameters that we tend to use. So mu is equal to the population mean, sigma is equal to the population standard deviation, and then we have statistics. So statistics describe a sample. They don't describe the entire population. And so we typically use X bar to be the sample mean, and we use S to be the sample standard deviation. And so these are different, and we need to understand that these are different. Getting the mean of a sample does not mean that that is the mean of the population. Now, we can do tests to determine how likely it would be that that would be the mean of the population, and we can use those to understand what within a confidence interval, what the population mean might be. So overall, I hope this helps give you an understanding of the difference between population parameters and sample statistics. If you want full access to these videos ad-free, I would check out my Research Mastery Academy. You can also download these slides are available within the Research Mastery Academy as well. I will leave a link below to that. And if you're struggling with learning statistics, I would check out this entire series starting from the beginning, which goes over statistics for scientists. I hope you enjoyed this video, and I look forward to seeing you in the next one.